Hello everyone and welcome to Mathematics Folio. Let us solve a question from definite integration based on its property. Let us see what is the question. So the question says that evaluate integral 0 to 1, sigma n is from 1 to infinity, integral part of 2 raised to the power n x upon 3 raised to the power n dx. What is the beauty of the question? I would say that beauty of the question lies in the different concepts that are being used for solving this question, be it the properties of GIF or the sum of infinite GP or the properties of definite integration. Well, let's start solving the question. And what I'm going to do is my first step in solving this question will be replacing this integral part function with the function and the fractional part. That means I'll be replacing it with the number and fractional part. Of integral part of 2 raised to the power n, I'm going to write it as 2 power nx minus fractional part of 2 raised to the power n x. This is how we will be starting the question. Okay, let's see what the integral will become. I'm going to write this integral as I, and the integral I will now take the form integral 0 to 1, sigma n is from 1 to infinity, 2 power nx upon 3 power n, minus fractional part of 2 power nx upon 3 raised to the power n dx. In my next step, I'm just going to separate these two terms. Okay, we will be separating these two terms. Sigma sign I'm going to shift inside the bracket, and the two integrals that we will now be getting will be sigma n is from 1 to infinity, 2 by 3 whole power n x dx. And the second integral will be integral 0 to 1, sigma n is from 1 to infinity, fractional part of 2 power n x upon 3 raised to the power n dx, right? So these are the two parts or two integrals that now we have to handle one by one. I'm going to name this integral as I1, this one as I2. I'll start with I1. I1 mein you can notice that this is an infinite GP that we are getting. The sigma is on n, so x can be treated as a constant. So I will write my answer. The integral I1 is integral 0 to 1. Now, infinite GP has the first term 2 by 3, and the common ratio is also 2 by 3. So I just applied the general formula that we have for infinite GP and see what we are getting. This is integral 0 to 1, ultimately turns out to be only 2x dx. Or you can say the integral is x squared, which after putting the limits reduces to 1. So I1 is over, and now we'll be proceeding to I2. So the major part of the question is actually I2, how we are going to handle it. The question says that you have to integrate 0 to 1. Sigma n is from 1 to infinity. Then we have fractional part 2 power nx upon 3 power n dx. What I'm going to do here is, first of all, I'm just going to interchange the sigma and the integral sign over here. How we are going to write it? We will be writing it like this. This is sigma n is from 1 to infinity, integral 0 to 1, fractional part 2 power nx upon 3 raised to the power n dx. For proceeding further, see, we cannot integrate it like this. So what I'm going to do, I'll use a substitution which says that 2 power nx is equals to a new variable capital T. That means actually you are putting x as t upon 2 power n, and that's why you're going to replace dx. You will be replacing dx with dt divided by 2 power n, right? I'm using all these substitution and the values of dx in this integral. You can see that I2 will take the form. Sigma n is from 1 to infinity. Lower limit for t is 0, while the upper limit has become 2 power n. Then we are getting it as fractional part of t. Denominator has not changed. Dx is being replaced with dt by 2 raised to the power n, right? This is what we are getting. See, the integral is with respect to the variable t. So 3 power n, 2 power n can be taken outside the integral sign. One thing that we can notice here is now we have a fractional part function, which is just fractional part of t. And we know that it is a periodic function with period 1. Since it is a periodic function with period 1, I'm going to rewrite this whole integral as sigma n is from 1 to infinity, 2 power n shifted in front of integral sign, 0 to 1, Fractional part of t will be replaced with now just t. Denominator 6 power n dt, right? This is what we are getting. Integration of t upon 6 power n, where n will be treated as constant. So I'm going to write it as sigma n is equals to 1 to infinity 2 power n upon 6 power n. T dt integral will be t square by 2, putting the limits 0 to 1. So we are just about to end the question. We are getting sigma n is equals to 1 to infinity 1 by 3 power n into 1 by 2, right? This is what we are getting. 1 by 2 can be thrown outside the sigma sign, and this infinite GP ka sum can now be evaluated as a upon 1 minus r. What we are getting here is 1 by 2 and one more 1 by 2, right? So it will become 1 by 4. This is the value of I2. The question says that I need to evaluate I, and what is I? I is I1 minus I2. We evaluated the value of I1 as 1 and we got the value of I2 as 1 by 4. So now let us complete the question and get the answer to the question. So answer to the question means now you can say that it will be 1 minus 1 by 4. That means 3 by 4. So here is the answer to this beautiful question. Hope you have enjoyed this question. So please don't forget to like the video and share the channel with your friends and fellow aspirants. Thank you for watching. See you in the next video. Till then, bye-bye and take care.